Hello everyone. So today we will be solving the problem lowest common ancestor of binary search tree. So let's first understand what this problem is saying. Okay. Let me erase this and okay. Copy. Okay. Yes. So we have been given this tree, and this root is given to us, and we need to find the lowest common ancestor of the binary search tree. Please note that this problem is specifically mentioned as binary search tree. I mean, we had solved previously the problem of binary tree, wherein we used the approach that if we have found out the like, suppose we need to find p and q. We have been given two values p and q, and we need to find the lowest common ancestor of the p and q in a binary tree. Please note that now we are discussing the approach of binary tree, and also that approach that we have used in binary tree will also be applicable in bsta. The code will run. I mean, if you logically see why would the code run, I mean, it will be very clear to you, right? So suppose we want to find 9 and we want to find 7. So how would you do it? You will keep on traversing. Actually, you will use DFS. You will go to the left, and then you will go to the right. Okay. So after going to the left and after going to the right, whenever we find the value p, we will return from there 7. And suppose we find out 9 here. After traversing in the DFS code, we will return 9 from here. And if the left and right value is not equals to null, we will simply return this root value. I hope this code you might be familiar with. I mean, this was the code discussed before. So suppose we want to find the lowest common ancestor of 3 and 8. So you can see very clearly that the lowest common ancestor of 3 and 8 is actually 6. So how do we approach this problem? Suppose we have not been given this BST. We are just given this binary tree problem. So how will you do it? You will keep on traversing. You will go to 5. I mean, when you go to 2, that is not equals to P. So again you will go here. That is again not equals to P. So you will return from here null. Okay, similar fashion here you also return null. But when you come over here, you will find that 5 is among one of the nodes that we want to find. So we will not return null from here. We will simply return 5. And please note that from here we are getting null, and here we are getting a root node. Not root node, but we are getting a node which is not equals to null. And whenever you get, suppose you get this situation, what you should return from here? You should return 5. So this approach we had discussed, and now for the clarity, if I show you the code of this, okay, okay, like, this is the code that will work actually for it. See, whenever we find null, we are returning root. I mean, we are returning null. Whenever we find p, we will return p. Whenever we find q, we will return q. Now, after returning, we will go to the left, and then we will recursively go to the right. And when we go to left, we will pass root left, and when we go to right, we will pass root dot right. So if in case my root and right both are null, what does this mean? It means that from the root, when we go to the left and right subtrees, we have not found our p and q. So from there we will return a null. And suppose if my left is equals to null, it means we did not find we did not find anything in the left subtree, but we find something in the right subtree. So we will return what? We will return right. Similarly in this case, and if all other things are not true, this statement will work. Return root will work if my root dot right is not equals to null and my root dot left is also not equals to null. What does this actually mean? This actually means that we have found out any a root uh, whose left subtree is not returning null and right subtree is also not returning null. So what will be the lowest common ancestor? Let's think about it. That will be the root itself. Okay, so that was about binary tree, but specifically in this problem we have been given binary search tree. So we should use the property of binary search tree. Okay, before moving ahead, let me talk about the time complexity of the code of binary tree. So the time complexity of the code of binary tree will be O of n. Why O of n? Because we are using DFS, right? And DFS takes O of n time complexity. But we can optimize it. Like if we have been given a binary search tree, and the binary search tree has a very special property. Any node lying to the left of a root will always be smaller than the root value, and any node lying to the right of the root will be always larger than the root value. And the time complexity of traversing in a BST is O of log n, where n is basically the number of nodes. So that is basically we are traversing in the height of the binary tree. Okay, now that was all about the theory of binary search tree. Now let's proceed to the question. What the question was asking. Suppose we want to find 2 and 8. We have been given P as 2 and Q as 8. How do we do it? So simply this is 2 and this is 8. We start from the root node, and here is the path divided into two sections. Okay, please mark my few words. Like I just said, here is the path divided into two sections. Now let us find out the lowest common ancestor of 0 and 7, right? How do you do it? So see, from here you go to here, and here you go to here. So where is the path divided? The path is divided at itself. So what will be the answer? The answer will be 6. Let us take more examples for better clarification. Suppose I take 3 and I want 0. Like I have P and Q as 0 and 3, and we want the LCA of 0 and 3. How do we do it? We go from here, we check here, where will my 0 and 3 lie? Since it is a binary search tree, so 0 and 3 will lie. If 0 and 3 is less than 6, they will lie on the left side. That is 0 and 3 is that is less than 6. So my recursion will go in this direction, and my this whole section will get eliminated. My 0 and 3 will not lie over here, and this portion will never be checked. So we saved a bit of our time complexity right now. Like we had initially O of n time complexity, we optimized our code and wrote O of log n time complexity. I hope this is clear. And that is a big optimization. Okay, so cool. Now we are at 2. Now we check where will my 0 lie. My 0 is less than 2, so it will lie on the left side. So just go on the left side. Where will my 3 lie? My 3 will lie on the right side of 2, so just go on the right side. But note, here one bifurcation is taking place. The direction is being divided into two parts. So this will be my what? This will be my lowest common ancestor. Okay, I hope till now it is clear. So if I write the pseudo code of this and try coding this approach by yourself after this much I have told you. So if my root dot val is less than p, and my root dot val is less than q. So what does this mean? It simply means that my root value is actually less than p and q, and my p and q are greater than root value. So where will my p and q actually lie? They will lie on the right hand side. So what we will do, we will call the solve function for root dot right. My root dot left will get completely eliminated, and I will pass this p and q. What if my root dot val is greater than p, and my root dot val is greater than q? In that case, what we will do, we will call solve function for root dot left, and we'll pass p and q. And if my both these conditions are not true, it's what does it mean? It simply means that we have p in one direction and q in the other direction, and we simply need to return root. Cool. Also right here written. So this is the code of the whole. Okay, now let's move to the code part and see. Yes, so this is the code. See, exactly similar to the, and if you run it, it will run fine. So thank you, and if you have any doubt, please ask me in the comment section.